I think one cut I always have on biology is it's sort of the field that people with lower IQs went into. It's sort of like people had bad math genes went into biology.
Any biologists in the room? 1, 2.
The infamous microbe, the zoospores of Batrachochytrium Dendrobatidis, or better known as BD. To me, this is the closest to the front line, the most hectic part that we can go to in the debate, the war, the ideological war of germ theory, contagion versus just getting sick, not because of the germs that may have rose in occupation. Why is it why is it the most hectic part? Well, it doesn't matter why I said that. Here is a report. In this report, all these people are involved in the making of the report. We are given some information. You can actually make a living inside the crayfish. The crayfish can actually be harmed by some of the chemicals that are produced when this fungus is making a living. We have found this because some of these crayfish were experimented upon, properly experimented with controls in place to make sure that it wasn't just some other thing that was harming these crayfish, just the chemicals alone without the microbe, the chemicals that result when the microbe is metabolizing these chemicals in varying dilution, cause varying rates in proportion of damage to the crayfish. Crayfish gills, they recede when this crayfish has more of this fungus in it, and this does not clash with my interpretation of how this works, being a non-contagious disease, despite the fact that this fungus can grow on one crayfish and have offspring that grow in a different crayfish, and the chemicals that result from their activity can harm the crayfish. I'm looking at why the crayfish are in a position to harbour these unfortunate situations whereby chemicals are produced that harm the crayfish. It is noted here that when the crayfish have this BD fungus detected in them, these amphibians also have it detected in them. I mean to say, when the rates are up of detection in an area coincides with between crayfish and the amphibians of certain species. It was found that also simply that there was more of this fungus detected in amphibians when there were yabbies, crayfish present that hadn't been detected, that hadn't had BD detected upon them in them. So it was also detected that in the springtime, this is more active, this BD fungus and these crayfish, and so is the BD in the amphibians, to say as well. So there's this correlation, BD activity and BD, or just BD activity between crayfish and amphibians. And these experiments, gill recession, the experiments, they show, as I said, I'll say now, that just the chemicals alone, not including the microbe, these are enough to kill crayfish. Here we have this experiment where these frogs were tested for the BD fungus before the experiment, and they were negative, and some became BD positive. During the experiment, without any exposure to the BD that they were experimenting with. This was one of the control frogs. This frog was tested to see if the BD was isolated from the frog and analysed and found to be a different strain to the one that was being used in the experiment. So with that other experiment, this one, actually I might not have mentioned, but one of the experiments contained in this report demonstrated that you can harm tadpoles in a way that makes them end up growing a certain kind of fungus, also featuring in the disease, this BD fungus, a certain kind of strain. If you get these crayfish that have been affected, maybe heavily dosed with BD fungus, or just find some in nature that have a lot of this BD fungus growing inside of them, and they'll probably have receded gills as well, as we found also in the report. These problematic crayfish that are going through issues, some of them have BD and fungus in them. You can put them in with tadpoles and see the difference between putting the tadpoles with those crayfish and putting the tadpoles with crayfish that aren't going through this issue, whereby for whatever reason the situation in their intestines, they are growing this BD fungus. You can see the difference. This supports a theory that the crayfish are actually transferring the BD fungus and acting as reservoirs for BD. So what I was originally coming here for is because I wanted to say that when these tadpoles have had issues caused by just being in the same water in the same cup as these crayfish that have BD growing in them, the BD that grew in the crayfish, in the tadpoles, that may have been a different strain of BD. The tadpoles may have just became chemically problematic once they were sharing the water with the crayfish, and then their skin cells, the skin cells couldn't actually get it together. The chemistry was broken, and rather than put skin cells together, they just got all these protein coming out in this kind of way, and the fungus is just seeing all this food there and it's going, oh well, there's me, that's me, I'm going to get that, and I'm going to produce more spores. And the fungus spores that took off and started growing in that situation where the cells aren't coordinating effectively. The zoospores may have already been in the tadpole, on the tadpole, even though the tadpole may have been PCR tested. The zoospores still can be there, as basically everyone who knows about this stuff, and these people verified, or they didn't even verify it, it just happened to be verified. And then we have this experiment where for 30 days frogs were forced in contact through some liquid with 10,400 zoospores per milliliter. The zoospores were replaced weekly. The frogs that had the zoospores died significantly more than the frogs that didn't have the zoospore, that also had a forced contact with this liquid without any zoospores in it. Not even a different kind of zoospore or some kind of protein package, no control like that. We don't have anything like an enclosure of frogs with just a little culture of BD introduced to the frogs in a way that's not interfering at all with their environment or their body, or not, the frogs aren't held down underwater or in water or up in a tree. Throughout the experiment they had a normal frog life, and the introduction of the microbe is quite consistent with reality of someone bringing a dirty boot from a different country and walking through a rainforest, accidentally starting an extinction, or even just a frog jumping out of their bag because they're naughty and they brought it over or whatever, or the frog came over on a boat or something, or on a bird's stomach, I don't know. Nothing like this to show that this BD fungus is actually something that can cause disease itself. Basically anything that's made out of atoms and you apply it to an organism in a specific way, you can cause disease with any particle. What I mean when I say we don't have anything that shows BD can cause any issues to any organism, I mean we haven't reenacted the scenario that occurs in reality, and demonstrated that BD has caused disease.
that could improve it quite a bit. Physics might be harder. We seem to not be making progress on string theory, and maybe we're not going to make a lot of progress there because you've had smart people working on that. So that's one I'd be a little bit more agnostic on what you could do. But biology, I think you could do a lot better. And